All right, let's try this. What are variables? In science, we talk about variables all the time. They're in our experiments. Sometimes we intentionally change the variables. Sometimes the variables are the things that we are measuring. So to have a true definition or something to kind of go by, variables are factors or conditions that affect the result of a situation. They are often tested in an experiment. So now that we know what variables are, I want you to think about them. Look at each of these scenarios that we have right here, and I want you to think about and make a list of what you think the variables in these things might be. Go ahead and pause your video and think about it, because you're going to be expected throughout the year to be able to identify different types of variables. Okay, so variables that can affect a pizza. You may have come up with the amount of cheese, the type of cheese, thin crust versus thick crust, the type of sauce. Those are all variables that could affect the taste of pizza. Variables that could affect the sprouting of a bean seed. Temperature, hot or cold, the amount of water, the type of soil, the amount of fertilizer. These are all variables that could affect the sprouting of a bean seed. What variables can affect the number of fish in a lake, the number of predators, the pollution of the lake? These are just a few examples. You might have come up with some that are different, but you should hopefully be on the kind of right track of identifying what variables are. What variables can affect the speed of a runner in a 100-meter dash race? Genetics could be a factor. Maybe their shoes are a factor. Maybe the clothes that they are wearing are a factor. If the wind is blowing, those are a bunch of different variables that could affect the race. What variables can affect the taste of a soft drink? How long it's been open, the fact of is it diet or is it regular. You can kind of see how broad variables are and how they can affect things if we don't identify them, and they might skew our results in a lab situation. Okay, so we're going to identify 3 types of variables, and you can see on your chart in your notes where each of those are. So the first one is the independent variable. Sometimes we abbreviate this as IV. The independent variable is something that is changed by the scientist. It is what is tested or manipulated. Sometimes you'll hear it referred to as the manipulated variable. The way I remember it is because it starts with I. It's the one that I change. That's a really bad C. It's the one that I changed. Okay, so independent variable is the one that I changed. Our next variable, dependent variable. The dependent variable is something that might be affected by the change in the independent variable. So it's the one that's going to be affected. When we start writing our hypothesis and our problems for labs, your dependent variable is always going to be the one that's affected by the independent variable. So it's what you observe or what you measure. It's the data that's being collected during the investigation. So the dependent variable depends on the independent variable. It's your result. Sometimes you even hear it called the responding variable because it's responding to the experiment. Our final type of variable is our controlled variable. Our controlled variable is not changed. It's sometimes called the constant. It's what makes the fair test. So earlier when we were talking about pizzas as an example, you would have to set up some controls in order to compare what was going to be the best pizza. If you were comparing what kind of cheese, then they would all have to have the same crust. If you were comparing what sauce, they would need the same crust and the same cheese. And so you can kind of see where you have to really think and put in some detail in identifying your controlled variables. A control group, this is some confusion sometimes, a control group does not receive the independent variable. So a control group is completely left alone so that we can go back and kind of compare things to. An experimental group is going to receive the information or the independent variable. It's what we're going to be testing. So make sure you kind of know the difference between those two. You'll find that throughout this, it's really important to study your vocabulary so that you don't get these words confused. It can be very easy to get them confused. We're going to go over a couple of different examples and kind of get you thinking. So here's an example. A students of different ages were given the same jigsaw puzzle to put together. They were timed to see how long it took to finish the puzzle. We've been working in class on underlining and identifying important things. When they're describing a experiment to you, I want you to go ahead and get in the habit of writing initials over it. So we've got different ages as important information, same jigsaw puzzle as important information, and that they were timed. So we're going to try and identify which piece is which, okay? Students of different ages were tested, or were given the same jigsaw puzzle to put together. So the fact that it was the same, this right here is going to be, I'm going to draw down here, this is going to be our control. They were all the same. And then the fact that they were different ages, this is our independent variable. It's what we're testing. And then the fact that they were timed, that's what we're measuring. That's our dependent variable. So start getting in the habit of going through, identifying these things, and labeling your independent and dependent variable so that you can distinguish between the two. We've got some more practice to do. So this is just going through and pulling out the information from what we had. So the independent variable, like we said, the age of the students, that's what we changed. The dependent variable, the time it took, that's what we were measuring or observing as a scientist. The controlled variable, this was the fact that they were the same puzzle. So we did a good job on this one. Okay, the next one I want you to try on your own and see how you do. The higher the temperature of water, the faster an egg will boil. You go ahead and you practice identifying which part of the experiment is each of these. Okay, hopefully you identified that the higher, wrong tool, give me a second, that the higher the temperature of water, the faster the egg will boil. So, what is the thing that we changed? We changed the temperature. That's our IV, our independent variable. We measured how fast, that's our dependent variable. And hopefully our constants is that they're the same size and type of egg. This would be our constant. So let's check. Looks like we did pretty good. The temperature of water was our independent variable, the time it took to cook was our dependent variable, and our controlled variable was the type of eggs. All right, last one. Again, I want you to try and practice this one on. The temperature of the water was measured at different depths of a pond. Go ahead and underline on your own and try and identify things on your own. All right. temperature of water was measured at different depths of a pond. The temperature is what we are looking at. We are changing the depths. Temperature is what we're measuring. So because we're measuring it, that's our dependent variable. Different depths is what we change. That's our independent variable. And the fact that it's the same pond is going to be our control. Or sometimes people say constant. We got it right again. The depth of the water is our independent variable. The temperature is our dependent variable. And, the thermometer is the controlled. The pond would also be the controlled. So, last thing we need to look at when we are talking about independent and dependent variable is graphing, because specific variables go on specific axes. So that's what we're going to be looking at next. All right, this acronym, dry mix, is what we use to help us remember which goes on which axis. So the next few slides, or the next slide, will go through and explain to you exactly what dry mix is. So dependent variable, that's your D, responding on the y-axis. So your y-axis is always, let's back up, I wrote this backwards. This is my y-axis. But if you always get in the habit of starting it off where your y-axis is like a big D, this is going to stand for dry mix. Dry, dependent responding y-axis. And if you make your x-axis into a giant I for independent, this is going to stand for manipulated independent on the x-axis. So this helps us remember anytime we're collecting data. If we were measuring it, that was our dependent variable, that's what we're going to set up on our y-axis. If we changed it, that's what we're going to put on our x-axis because it's our independent or manipulated variable. We will spend a lot more time practicing this throughout the year, but you'll always have these notes to refer back to and kind of help you to differentiate between independent and dependent and to remember where they go on their different axes.